Starting off with physics, topic number 4A, part 1, that you have also given a read yesterday as well. Electric current. We are going to describe electric current as the rate of flow of charged particles and then make some calculations for electric current as well. Some particles have an
Mhm.
electric charge, Q, which is measured in the units of coulombs. And a charge
Columns
of a single electron, you should know, is minus 1.6 into 10 to the power minus 19. Then what would be a charge of a proton? Plus 1.6 into 10 to the
plus
power
one.
minus 19. This means that you have 1 coulomb of negative charge if you have collected together 6.25 into 10 to the power 18 electrons as shown in the equation as well over here. Now, the charge on fundamental particles such as electrons are fixed properties of these particles, and you cannot destroy this charge as well. It's always remaining conserved. And if this electric charge starts to move, we call it the flow of electrons, that the electrons have now started to flow. And this flow of electrons is known as electric current. The
Current.
definition of current is the rate of movement of charge and is usually a physical movement of billions of tiny charged particles. Such charge movements are often said to flow, and thinking of the flow of charge like the current in a river can be useful as well. And we will see how current splits and recombines at circuit junctions in a manner that is like water flow. Also, the total amount of water in a river at given time does not change, even if the river splits. This again shows the conservation of charge. Electric current occurs when a charged particle which is free to move experiences an electric force. If it can move, it will be accelerated by the force, and this movement of charge forms the electric current. Most electric currents are made from metal wiring in which there are electrons that are free to move, and we these conduction electrons which actually move through conductors and wires, they form the current as well. Any source of
Right.
electrical energy can create an electric force in order to produce a current, and the cell causes the electric force experienced by the negative conduction electrons, so they move through the metal. Now, metal का अगर आप structure देखो in metallic bonding in chemistry, what is it? It's a positive metal ions surrounded by sea of electrons.
Yes.
So all metallic current conductors have metallic bonding, which means that electrons can easily flow
Flow through
through
them.
these metallic conductors as well. Now, the direction of electrons is always from negative to positive. But if we talk about the direction of convection current, it is always from positive to negative. For example, if you look at a battery, the bigger line is always what? The positive terminal, and the smaller line is always the negative terminal. So the direction of the current would be like this. Clear?
Yeah.
SI unit for electric current is ampere, and it can be calculated by using the equation which is I is equal to Q over T. 1 ampere is the movement of 1 coulomb of charge per second, and for example, if a lightning takes 0.1 seconds to transfer 1150 coulombs of charge, we can calculate the current by using Q over T. So Q is 1150 divided by time was given as
Over
1.
0.1.
So 11,500 was the total current. And if you want to
Yeah.
find the charge, you can rearrange the equation current into time as well. Got it?
Right.
Good job. So if you want to observe the charge flow, we have another equation as well, which is the change in charge is equal to IT, right? And we can also find the number of electrons per swing as well. If capital N is number of electron and whatever the charge that you have calculated by multiplying current into time, if that charge is divided by the elementary charge, which is minus 1.6 into 10 to the power minus 19, total charge divided by 1.6 into 10 to the power minus 19 will tell you that how many electrons actually flowed in that particular seconds as well. Got it?
Yeah.
So this was the current given, this was the time given. First multiply them, find the charge, then divide the charge by the charge of one electron, and you can find the total number of charges as well. If the circuit
Which is
is
N.
more unusual, there may be other charged particles as well. We call them as charge carriers, which can move to form the electric current. For example, in the electrolytic processing of bauxite ore to produce aluminium metal, the bauxite is dissolved in cryolite. Why? Why is it dissolved in cryolite? Any idea?
Mm.
To lower the melting point. Got it? Because this bauxite
Yeah.
ore is what जो हम aluminium के extraction में use करते हैं, it was Al2O3. इसका इलेक्ट्रोलिसिस करते हो तो रिमेंबर आपके पास Al+3 जो होते हैं दे कन्वर्ट इनटू Al, इनकी रिडक्शन हो जाती है। गॉट इट?
Yeah.
इनकी रिडक्शन होती है, एल्यूमिनियम प्रोड्यूस होता है, एंड दिस सॉल्यूशन हैज फ्री एल्यूमिनियम आयंस व्हिच आर आल्सो एक्टिंग एज चार्ज कैरियर्स। इलेक्ट्रोलिसिस भी क्या है? इट्स अ चार्ज कैरियर। इलेक्ट्रोलाइट इज अ चार्ज कैरियर एज वेल, एंड दे विल मूव बिकॉज ऑफ द इलेक्ट्रिक फोर्स टुवर्ड्स द नेगेटिव कैथोड। देयर इज एन इलेक्ट्रिक करंट दैट मस्ट ऑब्जर्व, और अगर आप दोनों वायर्स प्लेस करोगे इस इलेक्ट्रोलाइट सोल्यूशन में, एक करंट प्रोड्यूस होता हुआ नजर आएगा। व्हाई डू यू सी a volt? Why is a voltmeter connected to an electrolysis experiment? Because the electrolyte contains electrons, and there are electrons flowing as well from anode to cathode, right? Cathode is the negative
Right.
electrode, anode is the positive electrode, and that is why a current is also observed in a voltmeter during electrolysis as well, because that electrolyte
Yeah.
is also acting as a charge carrier. As the charge on an electron is fixed negative amount, we can easily calculate the charge on any ion, and this would be important in a situation where ions were moving as the charge carriers in the electric current as well. Got it?
Yeah.
So charge is a fundamental property of some particles. It is the cause of electromagnetic force and a basic aspect of describing electrical effects. Coulomb is the unit of measurement for charge, and 1 coulomb is the quantity of charge that passes a point in a conductor per second when 1 ampere of current is flowing in the conductor. Amount of charges, सिंगल इलेक्ट्रॉन पे क्या है, -1.6 इंटू 10⁻19। करंट का हमने फॉर्मूला पढ़ा विच इज Q/T। Q का फॉर्मूला हमने पढ़ लिया विच इज I/T, एंड नंबर ऑफ इलेक्ट्रॉन्स का हमने फॉर्मूला पढ़ लिया Q/the elementary charge 1.6 into 10⁻19. Ampere is the unit for measurement of electric current, where we can define it as 1 ampere is the movement of 1 coulomb 1 C of charge per 1 second. Got it?
Right.
So, if we discuss the electrical energy transfers, we should know the difference between electromotive force and potential difference as well. Then, how do we calculate voltage, and what are simple electrical circuits as well? For any electrical circuit to be of use, it has to act as means of transfer energy usefully as well. The circuit must have at least one component that can supply electrical energy, and it will also have components that transfer this electrical energy to other stores, and at least one of these stores of transfer of energy will be useful to its purpose. For example, in a bicycle light, there will be a cell that transfers electrical energy from a chemical reaction, and a lamp that might transfer some of the electrical energy as light energy as well. What if there's a speaker attached? A speaker would convert electrical energy to sound energy. What if there's a heater attached? Electrical energy would be converted to
To heat
thermal
energy?
energy. So, voltage क्या है? Voltage एक quantity है, the amount of energy that a component transfers per unit time. Now that component, if it's a battery, for example, or if that component is, let's say, a bulb, दोनों में फर्क है। अगर वो voltage, the amount of energy, if it's being transferred by the cell or a battery, we call it EMF. But if it's being transferred by any particular component to other forms of energy, let's say ये bulb है, ये light energy give away करेगा। EMF तो क्या है?
Mm-hmm.
EMF is always electrical energy. But the other
Yeah.
components, their voltage is known as potential difference.
Potential difference?
Exactly, because that's not always electrical energy. Electrical energy in a bulb
Yes.
is converted to light energy as well. So voltage can be found by energy transferred per coulomb charge, or we also call it work done per coulomb charge as well. For a supply voltage, a component which is putting electrical energy into a circuit, the correct term is EMF, which is 1 joule of energy being supplied to 1 coulomb of charge passing through it. E is equal to E over Q. For example, a bicycle lamp was powered by a cell. Now that cell has a EMF of 1.5 volt, but this bicycle lamp has a potential difference of 1.5 volts. Got it? क्योंकि वो उस
Yeah.
इलेक्ट्रिकल एनर्जी को लाइट एनर्जी में कन्वर्ट कर रहा है, बट सेल ने आपको जो 1.5 वोल्ट दिया, वो सेल ने आपको दिया ईएमएफ। तो वोल्टेज की दो टाइप्स हैं, potential
Right.
difference and EMF.
EMF.
Potential difference is for a component which is now changing the electrical energy to different types of energy. EMF is always electrical energy. EMF can't be any other
Yeah.
forms of energy. So
But potential difference can be thermal energy.
any kinds of energy.
Convert from electrical energy to
Yes.
thermal, for
क्योंकि
example.
potential difference कौन सा voltage है? The voltage that has been transferred from EMF to other forms. जैसे कि ये
Right.
इसकी भी definition same है, but the energy being used over here could be referred to as work done, because work done क्या होता है? Transfer of
Uh,
energy.
Yes.
For example, if the bicycle light produced light with a potential difference of 1.5 volt, then this LED would also transfer 1.5 joules of electrical energy to thermal energy. आपके पास EMF क्या था? 1.5
Mm-hmm.
volt. Potential difference क्या है? That is also 1.5 volt, but it is converted. वो जो आपके पास
Into
1.5
joules?
joules electrical energy थी, that has been converted to 1.5 joules thermal energy now. Got it?
Right.
Good. The electron volt is the unit of energy that is usually used for subatomic particles. V is equal to E over Q. जैसे कि अगर हम बात करें, if an electron is accelerated by a potential difference of 1 volt, then आपके पास क्या करेंगे? E is equal to capital V into small e. You can find the energy or the electron volt for one electron as well, which would be equal to 1.6 into 10 to the power minus 19 joule. This is the energy that is used to move one electron in a circuit. A model is a
Right.
way of thinking about an idea or phenomenon which order to helps us understand it better. For example, as the structure of an atom is too small to see, it is common for people to imagine it to be like that of planets orbiting the sun in the solar system. There are many aspects of this model that do not correctly represent an atom. However, there are some aspects that help people to think about atoms more clearly. Electricity has many aspects that are not visible to us in everyday life, and physicists often use models to explain some of these, and all models will have limitations as well. So, it is important to evaluate the strengths and weaknesses of any model to make sure that you do not rely too heavily on it as well. One model that you could use to try and understand is the transfer of energy in an electrical circuit. So, you should always know how to make an electrical circuit as well. Now this is an example of another model as well जहाँ पे आपने एक change in height भी represent किया. That makes it actually easy to understand how was the gravitational potential energy the highest at top. फिर जैसे जैसे height कम हो रही है we can see it by the model कि GPE lose भी हो रहा है और बिल्कुल lowest level पे minimum GPE कैसे था. The skiers on the lift gain potential energy, which is representing electrical energy in this analogy. By the time they have all skied back down through the runs and over the obstacles, they have lost all that GP again and back to the same level as before they started. This illustrates the principle of conservation of energy in an electric current, and if moving in a given energy by a source of EMF, it will transfer all that energy on its journey around the circuit
Potential
through the
difference.
various potential differences. सो ये भी एक पोटेंशियल एनर्जी है. जैसे बैटरी ट्रांसफर्स होते हैं वो इलेक्ट्रिकल एनर्जी देगी लेकिन कन्वर्ट आपका कुछ भी हो सकता है जो पोटेंशियल डिफरेंस होगा. So notice that although the picture in figure D has skiers and snowboards, for simplicity we only refer to the skiers. So what is voltage? Can you tell me? Read the definition of
A
voltage.
voltage is a measure of the amount of energy of a component transfers per unit of charge passing through it. It can be calculated by the equation voltage is equal to energy transfer joules over charge passing columns.
What is EMF?
EMF, a voltage as defined above with the energy coming into the circuit. Potential difference, the correct term for voltage of a component that is using electrical energy in the circuit and transferring this energy to other stores. Electron volt, the amount of energy an electron gains by passing through a voltage of 1V. 1E electrical volt is equal to 1.6 times 10 power minus 19.
Good. And if you convert it into megavolts, mega electron volt, तो वो into 10 to the minus 13 बन जाएगा. So now we are going to look at Ohm's law and different IV characteristics of components as well. The movement of electron through a circuit is caused by electron force that an EMF generates. Thus, an EMF could be said to drive the current around a circuit, and a higher voltage EMF would be expected to do this more as it creates a stronger force on the charges, so more of them are driven around the circuit faster, resulting in an increased current. The electric force is directly proportional to the voltage, so we could expect the current to increase as well when we increase the voltage as well. Electrical resistance is considered to be the opposition to the current. If current is flowing in this direction, the resistance would always try to oppose it and decrease the current flowing as well. Resistance is equal to voltage divided by the current, or voltage is equal to current into resistance as well. V is equal to IR. If the current is proportional to the voltage driving it through a component, we call it an ohmic conductor, as this means it follows Ohm's law. The proportional relationship can be used to find the resistance of the component, and you can see that R is equal to V over I. If V is 4, current is 0.18, resistance would be what? 22 ohm. So for an ohmic conductor,
Right.
the answer to the calculation of the resistance would be the same for all voltage. और ohmic conductor का मतलब ही यही है that the voltage is always proportional to the current. All ohmic conductors would also follow the same relation as well. That as you increase the voltage, the current is also going to increase in a straight line passing through the origin. This gives us a proof that they have a directly proportional relation. Got it?
Yeah.
For an electrical circuit design, we need to know how components will react when the potential difference across them changes. In order to ensure that the circuit performs its intended function under all circumstances, part of the specification of any component, we already have seen the graph. जैसे simple resistor का graph तो ये होगा. This is a graph for a simple resistor. Got it? And you have to memorize these.
Right.
ये IV ग्राफ किसका है? रेजिस्टर का है.
Resistance.
फिर हमारे पास एक IV ग्राफ आता है फिलामेंट का, which is
Filament
a
bulb.
curve one like this, an S shape बनेगा.
Yeah.
We can see that for a small voltage, current is proportional to it, and at higher voltages वो थोड़ा सा होता ही है कि फिलामेंट की वायर ना हीट अप होना शुरू हो जाती है, वरना it would go straight, but the thing is it's a filament. फिलामेंट इस पॉइंट से बियॉन्ड जब हम थोड़ा सा और एक्स्ट्रा वोल्टेज बढ़ाते हैं, स्टार्ट्स टू हीट अप, इसलिए करंट थोड़ा सा इंक्रीज कर रहा है, बट इन अ स्लोअर रेट. At hotter temperatures, metals have a higher resistance and the gradient was given off as reciprocal of the resistance. So the gradient becomes less towards higher voltage. Got it?
Right.
ये आपके पास किसका हो गया फिर? Filament का. Next, we
Yeah.
have it for a diode. Diode is a component that ensures that the current flows in one direction. And this is how it is for a diode. क्योंकि diode एक direction में जाएगा. Either negative or either positive. Because diode का काम ही ये है that it ensures that the current travels in single direction. So either it's gonna be positive or it's gonna be negative. And over here we can see that it's a positive forward bias diode. So only आपने जैसी voltage थोड़ा सा एक threshold voltage cross किया ना, it has increased at a maximum value of current. So this is a graph for diode. We can see that a diode only conducts in forward direction, and so there is a zero current for negative voltages. ये जगह खाली है, the negative one. It also requires a minimum voltage in the forward direction, and the threshold voltage is typically around only 0.6 volt. जैसी वो threshold voltage cross होगा, threshold is what? The minimum voltage to get the diode to work. The curve for the diode will be looked at in detail in later chapters as well. The fourth graph is
Right.
for a thermistor.
Thermistor. I drew all these.
Yeah, I know. Good job. ये सारे याद रखने because one of these would be asked in exam. Clear?
Okay.
यहाँ पे you can see that as you keep increasing the voltage, the current starts increasing at a higher rate और higher voltages पे और तेज जाएगा.
It continues, not like the filament lamp.
Exactly. थर्मिस्टर क्या होता है कि जब इस थर्मिस्टर का टेम्परेचर बढ़ेगा, रेजिस्टेंस डिक्रीज हो जाएगी एंड करंट विल इंक्रीज. दिस इज द
Voltage will
रिलेशन.
increase.
एग्जैक्टली. When temperature increases, resistance would decrease and current would increase. एंड वाइस वर्सा, अगर आपको सराउंडिंग्स का टेम्परेचर डिक्रीज करता है, रेजिस्टेंस बढ़ जाएगी थर्मिस्टर की और इसकी वजह से मोर ऑपोजिशन टू द करंट, सो करंट विल डिक्रीज. दिस इज हाउ अ थर्मिस्टर एक्चुअली वर्क्स. So for a thermistor, its resistance reduces with the temperature and the gradient of the line increases with the heating effect of the increasing current. The gradient represents the reciprocal of the resistance and the larger gradient value means lower resistance. This is a result of its manufacture from semiconductor materials whose atoms release more conduction electrons as the temperature rises and will be explained later on as well. Got it?
Yep.
So can you define resistance? Read it from here and then read Ohm's.
Resistance is the opposition to the flow of electrical current given calculated from the equation. Resistance is equal to potential difference over current. Ohm's law is the current through a component is directly proportional to the voltage across it, providing the temperature remains the same. The equation for this is often expressed as voltage is equal to current times resistance.
Good job. All clear?
Yep.
Good job.